Okay, welcome all the students. Today we are going to learn the topic. I think we have already started learning from the unit number 3. Okay, so from unit number 3, okay, we have already covered the basic transformation, translation, rotation, scaling with their matrix representation and composite transformation. So today we are going to learn or discuss the points, okay, other transformation. Okay, so there are the two types of transformation: reflection and shearing. Okay, so these are the reflection and shearing. These two transformation additional to these three basic transformation, okay, are called as or comes under this other transformation. Okay, so today's topic of discussion is reflection and shearing transformation. See, the point as per the syllabus or the topic of discussion is other transformation. Okay, so just now we have seen that the two-dimensional translation, two-dimensional rotation, and the two-dimensional scaling. Okay, translation, rotation, and scaling are called as basic transformation. Okay, so these are called as the basic transformation. Now, definitely all the computer graphics packages have the feature of translation, rotation, and the scaling. But there are some packages, okay, some computer graphics packages provide a few additional transformation, okay, that are useful in certain application. Means there are some computer graphics packages which along with this basic transformation, they provide some additional transformations are needed. Okay, so it is necessary for user to use this transformation, which are called as other transformation or additional transformation, which is provided by the computer graphics packages. Okay, and they are useful for different application. For certain application there is need to have more than these three basic transformation, some additional transformations are required. Okay, so which are these two transformation? So the two such transformations are reflection and shearing. Okay, so we are learning two-dimensional reflection and two-dimensional shearing. Okay, these are the two additional transformation which are called as or which are comes under the category of other transformation. So let us move to the next point. So first, now we are going to start understanding or start learning in detail what is mean by 2D reflection. Okay, so point of discussion now is understand what is mean by the two-dimensional reflection. Okay, so this is the first definition. What is the reflection? A reflection is a transformation that produces a mirror image of an object. So the 2D reflection, what it is going to produce? It is going to produce a mirror image of the given object. Okay. Now the so the mirror image of the 2D reflection. Okay. So it is possible for us that whatever the mirror image of the 2D reflection that we are talking about can be generated, okay, or it is generated relative to an axis of reflection. Okay, now it means that I want a mirror image of the object in the reflection, maybe relative to the x-axis, maybe relative to the y-axis, or any other axis. Okay, so it is relative to an axis of reflection. That is also possible to do it by rotating an object 180 degree. Okay, so if I consider I'm going to rotate the object by 180 degree, I may get the similar effect of the reflection about the reflection axis. Okay, so the first point indicate that the reflection is nothing but it is a mirror image of the object. The second point indicate that this whatever the reflection we are considering about that axis of reflection can be possible if I go for rotation of object by 180 degree. Okay, so if I rotate object 180 degree, it may possible for me get similar effect. Okay, about that reflection axis. Okay, now let us start understanding the first type of reflection. Okay, so I consider we are going to learn there are the four types of reflections are possible. Okay, so I'm going to have we are going to discuss the four type of reflection. The first type is the reflection about the line y is equal to 0. That is nothing but it is about x-axis. Okay, so generally we call it as the reflection about x-axis. Okay, the word we are using is the reflection about x-axis. That is also considered as the reflection about the line y is equal to 0. The meaning is same. Okay, so I'm taking the reflection about line y is equal to 0, means I'm going to take the reflection about x-axis. Okay, as shown in the diagram. So let us have the example of the this type of reflection with the help of diagram, and then we consider the transformation matrix. Okay, so now before considering transformation matrix, I want everyone to concentrate on this diagram. Okay, so this diagram shows, okay, as it is written the name of the diagram, reflection of an object about the x-axis. Okay, about the x-axis. So in this diagram, okay, we are considering this is my x-axis. Okay, that is what is written here. Okay, so I am going to take the reflection about x-axis. Okay, considering, now what is mean considering the reflection about x-axis means I consider this x-axis is my mirror. Okay, so I consider x-axis is the mirror. This was my original object. Okay, so this is my original object. I may consider it as a triangle. Okay, I think we have seen in so many practical examination the object as a triangle. Okay, and we may have given the edges of the or vertices of the object as a, b and c. Okay, but here we have given it as the vertices having the point 1, 2 and 3. So this is my point number 1. Okay, point 1, this is my point 2, and this is was my point number 3. Okay, now what we have to consider, we have to consider that this was our axis of reflection, x-axis. Consider this is my mirror. Okay, so generally in some of the textbook it is shown as this, indicate that this is my mirror. So x-axis is my mirror image or mirror. Then what we'll get, this 2 will be comes here as a 2 dash. Okay, I will get this 2 dash value, it is reflected. 3 dash is reflected here, and 1 dash 1 is reflected as 1 dash, and I will get this as, or this was my reflection object after reflection about x-axis. Okay, so this is what is shown here, reflected position of the object. Okay, I think it is easy for everyone to understand the reflection of the object about x-axis. This was my y-axis. Okay, and this is my, I'm taking the reflection about x-axis. Now if you observe this, okay, if you are going to observe the reflected object, you come to know that, suppose I take the example as a point number 2. Okay, suppose I take the example of point number 2. Suppose point number 2 is having the x value 10. Okay, see, I'm just writing it here. What is the value of x for the point number 2 is suppose 10. Getting me? And what is the y value? Okay, suppose I consider this is my y value. This is x value. Suppose y value I'm having as a 5. Okay, I'm just taking it as an example. Suppose x value is 10, comma, okay, y value is 5. Okay, now what will happen, you can find that I'm taking the about x-axis. So in that case the values of x will not change. See, the 2 dash x value is same. So 2 dash is having the x value 10 as it is, but the value of y is minus, and now the value of y is minus 5. Okay, so what is the value of y here? It is minus 5. This is the plus 5 value. Okay, so what this indicate, whenever I am going to take the reflection about x-axis, okay, the value of x not change, it will remains as it is, and the value of y will be flips, or it will be minus. Okay, so that is what our observation for the point 2, 3 as well as 1. See, suppose for here the value of 1 is suppose 15, so here it will be minus 15. What is the value of 1 point for x? Suppose x value I take it as, suppose it is 15 or 20, so it's same as it is. So x value remains as it is. Okay, let us look at the matrix representation of this. Okay, now in matrix representation, what is expected? The value of the object x value should not change, it should remain as it is, and the value of y should be minus. Okay, so let us look at the matrix representation of the same. Yes, this is my matrix representation. Okay, now you can find here the diagonal terms are used for the reflection. Okay, or we can say reflection about x-axis. X and y-axis, we are using the diagonal terms are used. Okay, so here in diagonal term, all of you are knowing this is my x value, this was my y value. If I consider it as a column, okay, we are having x and y, obviously this will be my h value, okay, homogeneous coordinate system, and here I am having this value, diagonal 1 value is there, diagonal values are 1. Here if I consider this is my x, okay, and this was my y, if I consider row wise, and again this is my h value that we are having, okay. So now here you can find the x column and x, this is my x, okay. So what is the x value? It should be 1, means it will remain as it is. Anything multiplied by 1, okay, I will get this value as it is. But here about the y value, if I consider, I am having in matrix this value as -1, okay, because I want the value of y should be flipped or minus, and the value of x should remain as it is. So this is 1, this is -1, obviously this is the diagonal value is 1 as it is, okay. H value we are keeping as and 1, and all other values are 0, okay. So the same thing that we have mentioned here, okay, so that just look at this, it keeps the x value same, okay. So reflection about the line y is equal to 0, that is x axis, reflection about x axis, it keeps x value same, and it is going to flip the y value, or the y value is minus, okay. So this was our discussion of 2D reflection about x-axis, okay. So similarly, okay, we are going for the next one, okay. So let us move to the next line to understand the next type of the reflection. So now we are going to learn the reflection about the line x is equal to 0, that is the reflection about y-axis, okay. So just now we have seen the reflection about x-axis. Now concentrate on the reflection about y-axis. It is shown in the diagram, and then we consider the transformation matrix, okay. Now if we look at the transformation matrix, and if we are going to compare it with the previous reflection, we can again find the similar things are there. This is my x value, this is my y value, again this is the x value, appropriate x value, and this is the y value, okay. Let's consider this as the x value and this is the y value. Now in the reflection about the line x is equal to 0, that is the reflection about the y-axis, indicate that the value of y remains as it is. The value of y will not change, okay, it is same, whereas the value of x will be flips or it is minus. So we are having this column, a diagonal value, it is -1, this is h value 1 as it is, and all remaining values are 0, 0, 0, okay. So let us understand this with the help of the diagram and the example, okay. So this the same thing just now we have explained, it keeps y coordinate value same, okay. This is my y value which is 1 as it is, means it is same, and it is going to flip or making the minus x values. X value will be minus, okay, x value is considered as a minus value, or it is going to flip the value of the x. Why it is instead of minus we have written as a flip, means already the value of x is minus, it will be positive. If it is positive, it will be negative, because we are going for the mirror image of the object, okay, about y-axis. So x value will flips, okay. Let us consider with the help of the diagram now, okay. I want everyone to concentrate on the diagram here. See, this diagram indicate the reflection of an object about the y-axis, okay. It is a reflection about an object, okay, reflection of an object about y-axis, okay. So this was my y-axis, okay, in the diagram. Yes, I'm going to highlight this y-axis now, and this y-axis should be considered as a mirror, okay. So you consider this is the mirror, okay. This was my original object, okay. So my original object is considered as this side, this having the 3 points, it is a triangle, we are having this point as 1, 2 and 3. So these are the 3 points of the original object triangle. When it is reflected at this side, considering the y-axis as a mirror image or y-axis as a mirror, okay, I will get this is the point which is reflected over here, which will be 1 dash, okay. This will be my 2 dash, okay, and this is my 3 dash. It is same with the field color, so that it is easy for us to understand the original object and reflected object, okay. So this is my reflected object position, okay. My object is reflected here, okay, and this is my matrix representation of the same. Now you can easily find, this is my, suppose I considered, okay, I take the example of 3 now. Okay, if I consider the example of the 3, assume that 3 is having the y value. Okay, I just take this point and this is my y value. Okay, what is going to happen? The y value of the 3 and 3 dash is same. Okay, y will not change. But what about x value? Suppose I am having the x value is -10. Okay, suppose I consider this is my -10 x value. Then what is going to happen? This value is going to flip. That's why I have written the word as flip. Okay, -10 into -10, I will get it as a +10, and I will get this reflected point, the C dash, having the x value 10. Y value is same as it is. Suppose y value is 5, then it will be remains 3, also it is 5, 3 dash it is also 5. Okay, so this is what we talk about the second type of the reflection. Okay, I just consider it as, this is the second type of the reflection, that is reflection about line y x equal to 0. That is nothing but reflection about y axis. Okay, so let us move or continue our discussion to learn the next point of the reflection. Okay, so I'm just moving to the next slide. Now here I call, okay, this as my third type of the reflection. Okay, I consider this was my third type of the reflection, type number 3. If we choose the reflection axis as a diagonal line, y is equal to x. Okay, see, first type we have seen the reflection about x-axis, reflection about y-axis, and now we are considering the reflection about the diagonal line y is equal to x. Okay, then it is called as the reflection about the line y is equal to x-axis. Okay, so we need to understand it with the help of the example. It is shown in the diagram and the transformation matrix that we are going to consider. Okay, now I will first show the diagram and then I will explain the transformation matrix. Okay, so it will be more easy for us to understand. Okay, so let us concentrate on this particular diagram. See, in this our 4 quadrant, see, we have divided our screen into the 4 quadrants. Okay, I just divide it into the 4 quadrants. Okay, so this was my first quadrant, correct? Okay, this is my, I consider it as my second quadrant. Okay, and I consider this was my third quadrant. Okay, and this is my fourth quadrant. Getting me? So I'm having this 1 2 3 4 quadrants are there. Okay, so divided the screen into the 4 quadrant. Okay, 1 2 3 and 4. This I extend this y to the minus y value, x to the minus x value. Okay, now in that case I'm having, this is my diagonal line. Okay, so here you can find this diagonal line y is equal to x. Okay, so this is dotted line, whatever I have shown here in this diagram. Okay, so this, definitely this line will continue in this third quadrant. So this was my line. Okay, this is the dotted line. See, this line is called as y is equal to x, and now I'm considering this y is equal to x as my mirror. Okay, so previously we have considered x-axis as mirror image or mirror, y is equal to mirror. Now I considered the line y is equal to x-axis. This is my diagonal line. Okay, so if I consider this is my 90 degree, this may be 45 degree. Okay, I'm having the angle as 45 degree. I will get this diagonal line. Generally this will be my 90 degree, okay, that we are having. Okay, so now in this particular case, okay, if I considered this is my line of reflection, so reflection about line y is equal to x. Now what is meaning of y is equal to x here? Means the value of y will be changed to x and the value of x will be changed to y. Very simple. Okay, so it is interchange of the x and y value. If y will become x and x will become y. So if you consider this is my original object now. Okay, this was my original position of the object. This is my 1, this is point number 1, this is point number 2, point number 3. So I want this should be considered as my reflection axis or reflection line. This should be considered as a mirror. So here I will get 1 dash value here. Okay, you can find it here, 1 dash value. 1 is reflected here, this is mirror. 2 is reflected at this side, this is my 2 dash, and the 3 is reflected here as 3 dash. Getting me? And now in this particular case the values will be interchanged, the values are considered to be changed. Okay, so meaning of y is equal to x will be, I'm going to swap these values, I'm going to change these values of x and y. So my transformation matrix for this particular purpose, okay, the transformation matrix that I'm using is, now for these lines, okay, you not using the diagonal value. See, you can find that the diagonal value, this is 0, this is 0, this should be obviously 1 because it is related to the homogeneous coordinate h. Okay, h diagonal value should be 1. But here you can find what the change we are having is the 1 is there, okay, so which is considered the, we are going to change the value of x and y. This is my x, this is my y, okay, and you can find, suppose this is, I'm taking it as a row. In this row the value of x, okay, to x will be 0, but here it is 1. Similarly here for this y, okay, the value second row, this value is 1 but y to y is 0. Okay, so this was my transformation matrix, okay, which I am using for the reflection about the line y is equal to x, and this is my y is equal to x line. Okay, y is equal to x axis. Okay, now it is, if you want to find one more example of this, let us consider what should be the value of 2. Okay, suppose I consider here the point 2. Okay, second point of my triangle, this point, I just want to consider this point. Assume the y value of this and x value of this. Okay, now suppose I consider the x value of this 2 point is 1. Okay, I assume it is only 1. This x value is 1, and suppose the y value I am having here is suppose 9. Getting me? So I'm just considering that the x value is 1 and y value is 9, because this is y value having the value 9, and this is the x value having the scale 1. Okay, now what is going to happen in this particular case is, whenever I am going to use the reflection about the line y is equal to x, that is what I told, x and y value will be changed. Okay, so what will be my value of 2 dash here? The 2 dash will be, what is the value of x? X will be changed to y. What is the y value for original point? 9. So that is changed to x, and so this is 9 comma 1. Okay, so there is a swapping of x and y value. Okay, now you just look at whether it is correct. Yes, see what is the x value here? I am finding this here for 2 dash. Okay, the x value is 9, and what is the y value here? Y value is 1. Okay, easily you can find it as, so that is what we are considering reflection about the line y is equal to x, y is equal to x, and this is the matrix representation for the same. Okay, I hope all of you understood this. Now there is these are the first, second and three type. Now the fourth type, okay, I just want to, yes, definitely we are going to the next slide to understand, but as I'm having this diagonal line, I may have in my 4 quadrants, quadrant number 1 2 3 4, I divided the screen into the 4 quadrant. Now I may have one more line which is possible, which is diagonal, and this is my line. Okay, so this line is called as y is equal to minus x. Okay, and that was our fourth type of reflection. So I'm just moving to the next point to understand the one more type of my reflection. Okay, so let us move to the next slide now. Okay, now here that is what I have written. If we choose the reflection, okay, again I say this was my, what is the type of reflection? This is my fourth type of reflection. Okay, it is the fourth type of reflection. If we choose the reflection axis as a diagonal line, but now my line is y is equal to not x, it is y is equal to minus x. Okay, so I'm going for the reflection about y is equal to minus x, then it is called as reflection about line y is equal to minus x. It is shown in the diagram. Okay, and let us look at the transformation matrix. Okay, so let us look at the diagram and the transformation matrix. Okay, we will concentrate on the diagram first, and then we'll come back to the transformation matrix. Okay, so as I told, I have divided the screen into the 4 quadrant. Okay, in that case, this was my first quadrant. Okay, this was my, okay, you can consider it as the second quadrant. Okay, this is my third quadrant. Okay, and this is my fourth quadrant. Okay, so we have divided the screen to 4 quadrant. I extend, this is the line again. Okay, now this is what I'm talking about. So this was my line which we called is equal to y is equal to minus x. Okay, it is showed with the dotted line. Okay, or I just, okay, want to, okay, mark this. Okay, this is my line of reflection. Okay, this is the line which call it as y is equal to minus x. Okay, this is the line. Okay, so I want to reflect the object by considering this line, which is nothing but y is equal to minus x. Okay, this is a line y is equal to minus x. Okay, again consider the same example of the triangle. This was my original object now. Okay, original object is having the value 1, 2 and 3. Okay, so original object is here. If I reflect this object now, considering y is equal to minus x, means I consider this is my mirror. Okay, I consider this line is my, which is passing from the origin, which is y is equal to minus x, and I consider this is my mirror. Okay, so I consider that I have put this mirror over here. Okay, or this is the line of reflection, and now this one will be here reflected as 1 dash, 2 will be reflected here as 2 dash, and the 3 will be reflected here as 3 dash. Okay, now here if you look at the values, then you can consider that definitely we have said that y is equal to minus x, definitely y and x will be replaced or it will be changed, but not only changed, but the value will be minus. Okay, y value is changed to not only x, but it is changed to minus x. Okay, so that's why we call this as a reflection about the y is equal to minus x. Now what it means is we are not only we are going to not only swapping the x and y values, we are not only interchanging the x and y values, but we are putting the, it is in the negative sign, so minus. Okay, so in previous case reflection about y is equal to x, here I am having the plus 1 and plus 1. Okay, but now I am taking y is equal to minus x, so this value is put to the minus 1, this is also minus 1. Remember, for the line y is equal to x and line y is equal to minus x, the off diagonal terms are responsible. Okay, and diagonal term values are 0 0. Okay, so diagonal term is 0 0, and off diagonal terms are going to affect to the reflection about the line y is equal to x and y is equal to minus x. Okay, as it is minus x, this value is minus 1, this value is also considered as the minus 1 value. Okay, and this is what we are talking about, the 2D reflection. Okay, so it is necessary for us to remember the transformation matrix of all the 4 types of the reflection. So we have learned the reflection about x-axis, reflection about y-axis. See, reflection about x-axis is nothing but we have written it is line y is equal to 0. Okay, and reflection about y-axis we have written it as line x is equal to 0. Then we are having the reflection about the line y is equal to x and reflection about the line y is equal to minus x. Okay, so these are the 4 different types of the reflection which are possible. Okay, now it may possible for us to perform the reflection from any arbitrary line. Okay, what is mean by any arbitrary line means other than this 4 type of reflection, it is possible to reflect the original object about any other line. Okay, so if that line is not passing, it may happen that I'm going to put the mirror anywhere. Okay, and it may possible to do it, but that point is called as reflection about an arbitrary line or any other line which is may not be passing to the origin. Okay, so in this is, but these are the 4 basic types of the reflection. Okay, and generally in the reflection we are taking the mirror image of the object. Okay, will be displayed on the screen. Okay, so this is all about the 2-dimensional reflection. Okay, so with this explanation I hope all of you understood the 2D reflection. So with the discussion, let us move to the one more type of the transformation. Okay, in other transformation we have learned reflection, and the second point of the discussion is nothing but it is shearing. Okay, let us move to the next slide to understand the what is mean by the shear effect or what is mean by the shearing. Okay, I'm just moving to the next slide now. Okay, so now we are going to learn the point which is called as 2-dimensional shearing. Okay, shearing. It is a shear effect. It is called as shear effect. Okay, of the transformation. Okay, now the first point is very important about this. A shearing transformation, a transformation that going to distort the shape of the object. Okay, so the shearing transformation will always go to distort, means completely the shape will be completely changed. Okay, if I am going to scale the object, okay, in that case generally I am going to double the size of the object, I am going to reduce the size of the object. Okay, but generally the shape remains as it is in the scaling. Okay, but in shearing, the shape of the object will be completely changed. Generally we call it as the distortion of the shape of the object. It is going to distort the shape of the object. The shape of the object will be completely changed. Okay, so that's why it is considered as a shearing effect. Okay, now such that, what is meant by the distorting the shape of the object is such that the transformation shape appears as if the object were composed of the internal layers, okay, that had been caused to solid over each other, and generally it is called as the shear effect, shear. Okay, shear effect, or it is called as the, and that transformation is called as the shearing. Okay, and the effect of transformation, just now we have written, it is called as the shearing transformation. It is called as the shearing transformation. Now the shearing transformation, we can say there are the two common shearing transformation are those that shift coordinate x values and those that shift coordinate y values. It's again that shearing effect. Okay, maybe in the x direction, maybe in the y direction, or it may be shifting the coordinate about the x values, or it may be shift about the y values. Okay, so we can go for x direction as well as the y direction for the shearing. Okay, now let us understand what was my shearing transformation matrix. Okay, so what will be my transformation matrix of the shearing? Okay, it is very important to understand this. Now you can find here, okay, the very important thing is the off diagonal terms are going to affect to the shearing. Okay, the shearing what we are using, we are using off diagonal term. Diagonal term values are 1, this is also 1, so diagonal term value is considered as 1 1, okay, in the shearing, but the off diagonal terms of the transformation matrix are going to represent my shearing effect. Okay, obviously this is I consider in the direction of x and y, so I take these values as a x and y direction. Okay, so this is the term which is going to affect to the sh. Okay, we may consider it as shx and shy. Okay, if I'm applying appropriately, I consider that this is the shx and shy value that we are considering. Okay, so now if these values are 0 0, okay, obviously there will not be any change. If this is 1, there will be change. If it's 2 3 something else, so this off diagonal term are going to create the shearing effect. Okay, so let us move to the next slide, okay, and we are going to understand the example of the two-dimensional shearing. Okay, unless and until we see the diagram or the example, we will not understand what is the shearing effect. Okay, so I'm just moving to the next slide now. Okay, now the 2D shearing example. Okay, let us consider the example. Now here, first I am representing it, the example, with the help of the matrix. Okay, now considered a unit square. Consider that I'm having a unit square. Okay, and now I want to find out the coordinate of the transform object, okay, when I'm going to apply this shearing transformation matrix. See, I'm going to apply my shearing transformation matrix where we have just now seen the diagonal terms are 1 1. Okay, so diagonal terms are 1, no issue with this. So here I am having sh value, so this value is 2. Okay, and it is in x direction, and where the value of y, here I am having it as a 0. So these are the two sh shearing parameters. Okay, so we are having it is in the, okay, 2 and this is 0, x direction, and this is y direction value, shx and shy we can say. And now we have to apply this transformation to the unit square. Okay, now what is mean by the unit square? Okay, what is my object? My unit square object should be represented into the matrix form. So see, that's why we are having this. This is my x star after shearing. This is my original object x, applied the shearing transformation t. Okay, now my original object x is nothing but it is my unit square. Okay, I'm considering the example that I'm having the unit square with me, and it may have the point. I consider these are the points of the unit square a, then this is the value b, this is the c point, and this is the d point of my unit square. Okay, so these are the a b c d point. Obviously this will be represented as the x value, and this is going to represent it as the y value. Okay, and this is my transformation matrix. Okay, I think a is having 0 0, b is having 1 0, c is having 1 1, d is having 0 1. I think I must draw the diagram. Next slide we are going to see the effect also, but let us understand, okay, it with the help of the example. I consider this is suppose my x and y value. Okay, this is my x, this is my y. I just try to plot the unit square on my screen so for easy understanding. Okay, suppose this is my value 0, getting me, and this is the value I consider it as 1. Okay, this will be the value 2 and so on. So consider this is my value, x is 1, this is my y value is also 1. Okay, I just changing the color, okay, so that it will be easy for you to understand. See, what is my a point? My a point will be 0 0. Okay, you can see here a is 0 0. What is the b? B is 1 0, x is 1, y is 0. So this is my 1 0 point. What is my c point? It is 1 1. Okay, so 1 and 1 means I think it will come somewhere here. Okay, and my d point is x is 0, y is 1. So this is my another unit square value. So what should be my object here? I'm trying to draw the diagram or the object here, which is my unit square. Okay, you can find this is my unit square and its appropriate representation. Okay, this is my a point, this is my b point of the unit square, this is c, and this is d point. Okay, and now this is multiplied with my shearing transformation. This is my shearing transformation. It is multiplied by 1 1 diagonal as it is. This is 2 and this is 0. Okay, so this was my transformation matrix. So what is my result? What is the answer I'm getting for x dash? The answer for x dash, I'm getting the a value. Okay, see the a value, or another a I say it is a dash. Okay, or a star. A star will be 0 0 after multiplication. This was my b star or b dash, it is 1 2. This was my c dash and this was my d dash value. So this is the effect. This is what the values of a b c d had changed. Okay, and now to understand or now to see the effect of this on to the how it this unit square will look like, or this my original object unit square will look like. I'm just moving to the next slide to understand the effect of the shearing. Okay, so let us move to the next slide. Okay, yes, the unit square before and after shearing. Okay, the unit square before how it will look like, and after the shearing effect how it will look like, it's shown here. Okay, so let us understand the diagram here. This was my a is my original object, this is my unit square having the value a b c and d. Okay, so these are my point, and we also seen the matrix representation of my original point. Okay, how the original point is represented we have also seen. Now after reflection, okay, or after performing the shearing effect, okay, after performing the shearing with the transformation matrix just now we have seen. So what how the uh, object will look like? So this is my object after shearing. Okay, the a value will 0 0 as it is. I think we have seen the value of b is 1 and 2, the d is okay, 0 and 1. Okay, and the c is I'm having the value 1 and 3. So this was my the unit square. Okay, actually my object is unit square here. Okay, so my original object is unit square, but it had changed to this particular object after shearing, and easily you can find that the it is complete distortion of my shape of the object. What was my original shape of the object? My original shape of the object was square, it is a unit square. Okay, but after applying the shearing, my object shape is distorted, it has completely changed, and that's why it is called as the two-dimensional shearing. Okay, so one thing we have to keep always in your mind is the two-dimensional shearing is going to distort, or it will result in distortion of the shape of the object. Okay, original object shape will not remain as it is going to change, and now I'm getting something. If you look at this particular object, you can find the shape of the object has completely changed. Okay, maybe I think we can say the values that we are having, it is related to this, okay, has completely changed, and it is going to change completely the shape of the object. Okay, or not, I'm not talking about size of the object. See, the scaling transformation, two-dimensional scaling, is going to change the size of the object. Okay, maybe the object is double, maybe the object is reduced their size. Okay, but the shape generally not affect if I'm applying uniform scaling. Okay, two-dimensional uniform scaling. But if I apply the two-dimensional shearing, okay, then the effect is, okay, we are not talking only about the size of the object, but it is going to change the shape of the object will be changed. So that is what is called as the two-dimensional shearing effect. Okay, so I hope all of you understood. Okay, these are the two types of the utter transformation. Okay, two-dimensional transformation. One is two-dimensional reflection, and the next is two-dimensional shearing. Okay, so these are the, so total we are having 5 types of the transformation that we have learned under the 2D. The same we are going to learn in 3-dimensional also. Which are these 5? It is translation, then it is rotation, scaling, reflection, and shearing. Okay, so we end our session here. Okay, thank you all.